Guys, Friday again, thank the Lord. Just a little video for you. I thought we'd do a little bit on sequence of operation today. Just one thing to bear in mind, guys, this is a more modern pre-mix appliance, and this boiler has 28 different fault finding codes. Okay, this is old atmospheric. And you know, in a lot of cases these are the type of boilers that you're working on, because these type of boilers, you've made manufacturers put these long warranties on there. So you know, at the end of the day, a lot of boilers that you attend are of the older type. So we'll address, you know, later technology as we move on. But one of the things that we need to understand is sequence. So this has got 28 fault finding codes. This one, the old atmospheric, and they're all the same. The top light depicts power, and the bottom light, when flashing, it's going to overheat for some reason. And if the bottom light stays solid, then it's gone to flame failure. Well, sorry guys, but yeah, these are handy to have all these fault finding codes, but the whistles and bells at the end of the day, you know, you're the engineer guys, you know, you're out there actually fixing it. And yeah, they're a good handy guide, but you know, train the trainer again, and let's be engineers. There's only two failures on any gas boiler, whether it be a pre-mix or whether it be an atmospheric. And one of those failures is attributed to an overheat situation, and the other is attributed to flame failure. And what we must get into as mindset, guys, is understanding the sequence, okay? Now, understand the sequence and understand the standard of a gas boiler. The sequence on gas boilers is virtually the same, because they all go through the same test house to get to the end sequence. So if we switch a boiler on, then the first component to energize is the pump. So, and the pump comes direct from the circuit board in older technology like this. If we look at, as we move on, some boilers may have some device like this. They may have a pump proving switch, where if the pump's not energized, then the sequence can't continue. But let's look at boilers that you're working on without flow switches and without, if you like, a pump proving switch like so. So we switch this type of appliance on, and the pump immediately energizes, and the pump comes direct from the circuit board. Now, a regular component to be sold is a PCB, but what you must appreciate, with all manufacturers, PCBs are pretty much bulletproof. So the only time I will actually tell you there's a problem with the PCB, if there's no power to the pump, the first line in the sequence, okay? Now, the standard says then, once the pump is energized, the standard is asking for the circuit board behind the panel to search for the APS, to search for the air pressure switch. Now this is very important, guys, because this is where you can actually buy a PCB unnecessary. I'll just swing around to this flip chart, okay? And what we've got here, this is an old type APS. Now, on very old appliances, we had 3 tabs, and on those 3 tabs there was 3 wires. One of those was common, one of them was normally open, and the other was normally closed, okay? So all of those 3 tabs were actually used. As time went on and things moved on, we found that we had 2 wires, but 3 tabs, and one of the tabs was covered with a red or an orange rubber boot. And then as time went on, we found 2 tabs, and the 3rd tab had disappeared. Well, it hadn't disappeared, it became a flat piece of metal on the APS, on the air pressure switch, because that flat piece of metal was still a usable part of the air pressure switch. And that usable part of the air pressure switch was the normally closed position, guys. Okay, so remember, we've now got the sequence of operation, the pump is running, then the standard says that the circuit board must search for the air pressure switch to see if it's in place before ignition can continue. And ignition continuing is the fan to run, okay? So, does it search from common to normally open, or does it search from common to normally closed, okay? Well, think about it logically, guys. If it searched between common and normally open, it would mean that you could link an air pressure switch out and walk away, and but basically you're leaving a bomb, okay? So the standard says that we don't search between common and normally open, we search between common and normally closed. So once it sees that there's continuity between common and normally closed, it knows that the air pressure switch is there, guys, doesn't it? And when it knows that the air pressure switch is there, then it allows the fan to energise. So that is the thing that will throw you off track where you would buy a PCB. It's not the PCB. Just remember what I'm saying to you. PCBs are bulletproof, guys. All manufacturers. Okay? Right, so let's just check this. Let's just have a look at this. So if I get my multimeter onto continuity buzzer, okay, and if I check, if I look via the MI and on the air pressure switch, it tells me which is common, which is normally open and which is normally closed. Before you attempt to fit an air pressure switch, just remember, guys, that these air pressure switches can have done 20,000 miles bouncing around at the back of you in a van. Is it going to work when you want it to work? So again, like we said yesterday, before you make yourself look a clown, just do a test outside before you take the air pressure switch in. And here I've got, if I go to the buzzer, if you just listen here, guys, I'm testing between common and normally closed. There I've got continuity. If I didn't have continuity between common and normally closed, bin it. Don't even bother to fitting it in the boiler. It's up the spout. It's buggered. Okay? Sling it. Okay? Right, so just to recap, we search, the standard says we search between common and normally closed. When it sees we've got continuity between common and normally closed, the ignition process is allowed to continue. And the ignition process basically is fan. Okay? Right, we're gonna reiterate that as we move on. Okay? Once again, guys, thank you for your time. Have a good weekend. Cheers.